Good morning, good afternoon, or good evening, depending on when you're watching this. Now we're going to look at angles in circles. And there are a few facts that you need to know when you are answering this type of question in an exam. First one that you need to know is you need to know that the angles at the circumference in a semicircle are right angles. Now we're told here AB is a diameter and 0 or O is the centre. So if that's the case, if that's a diameter, then this here is a semicircle. And if you draw an angle at the circumference in a semicircle, then it forms a right angle. So we know that if AB is a diameter, this is a semicircle, and the angle at the circumference would be a right angle. Now you have to know that. That will not be highlighted. You have to bring that fact to the question. Here we have another circle, and AB is a diameter. That means that we have a semicircle here, and no matter where you draw your angle to at the circumference, if it's a semicircle, a right angle is formed. So that is the first very important fact. The second fact that you need to be aware of is you have to be looking out for isosceles triangles in circle work. And the reason is, if you have two radii, we know these are the same length. So if that's a radius from the centre out to the circumference, from the centre to the circumference, that is a radius. So we know we have an isosceles triangle. And we know that in an isosceles triangle, the base angles are equal. So when we're dealing with circles, we're looking for isosceles triangles. Another very important fact is tangents to circles. Now, if a line is a tangent to a circle, then the line and the circle intersect in one point and one point only, like this red line is a tangent to the circle, and it intersects in one point and one point only. This line, this green line, it intersects in 2 points. It's not a tangent. And this blue line doesn't intersect at all. That covers all the possibilities for a straight line in a circle. No points of intersection, 2 points of intersection, or 1 point of intersection. So 1 point of intersection means that it's a tangent. And the very important thing is, if a line is a tangent, when you draw the radius to the point of contact, a right angle is formed. So when you draw your radius to the point of contact, a right angle is formed. So that's the centre. You draw the radius to the point of contact, a 90-degree angle is formed. So these are the things that you have to bring to the questions. Okay, let's do some questions, the way they typically appear in an exam. So you're presented with information. AC is a diameter and O is the centre of the circle. CD is a tangent to the circle with C the point of contact, and BCD is 54 degrees. Find the angle CAB. So you're interested in finding this angle. Now, you can't launch into that immediately. What you are bringing to this is all of the facts that we mentioned. AC is a diameter, so here we have an angle at the circumference in a semicircle. So we know this is a right angle. We're also told that CD is a tangent. Now, if we draw the radius to the point of contact, it forms a 90-degree angle. So that angle makes a right angle. And we know that this is 54 degrees. So if this is 54 degrees, then we can work out that missing angle. That would be 90 minus 54. So the size of that angle would be 36 degrees, making it add to 90. Now we have this triangle here, and we know that angles in a triangle add up to 180. So we've got 90 degrees and we've got 36. We've got 126 degrees. So we have to add here, must make it add up to 180. So we've got 90 degrees and 36, 126. So this angle must be 54 degrees. And that's the angle we were asked to find, CAB. Angle CAB is equal to 54 degrees. Now we work that out using these two facts. Angle at the circumference is 90, and if this is a tangent, then when the radius is drawn to the point of contact, a 90-degree angle is formed. Let's look at another couple of questions then. Number 9. In the diagram shown, BD is a tangent to the circle. BD is a tangent to the circle. Angle BAC is 28 degrees. Calculate the size of angle CBD. So we want the size of CBD. We want this angle here. Now again, we're going to make use of these facts that we were given. we know that this angle here is a right angle. Now here we have an isosceles triangle. These are both radii. So if we look at that triangle there, this has to be 28 degrees. Now this is an angle in a semicircle, so that's a 90-degree angle. So we know that this must be 62 degrees. Now we also know that if this is a tangent, this also is 90 degrees if that line's a tangent. So that angle plus that angle must add to 90, so that would be 28 degrees. So angle CBD is equal to 28 degrees. And again, these are the facts that we were using. Number 8, A and B are points on the circumference of a circle, centre O. BC is a tangent to the circle. Angle ABC is 66 degrees. Calculate the size of AOB. Here's AOB here. This is the angle that we want. Now again, if this is a tangent, that means that that's a right angle. The radius drawn to the point of contact. If this be 66, this here must be 24 degrees. Again, we've got an isosceles triangle. So if that's 24, this must be 24. 2 times 20, 24 and 24 is 48. So it's 180 minus 48. That would be 132 degrees. So we were asked to work out angle AOB is equal to 132 degrees. These are very common questions, and it's just harnessing these facts that you have to know. Thank you.